Hi guys, Dr. Rob Barrington here with some more nutrition advice and analysis. I wanted to make a quick video to clear up the difference between fructose from industrial sources and fructose from fruit. Now, fructose is quite a common dietary sugar. It's present in fruit, and it's present in much smaller amounts in some vegetables as well. Fructose is often called fruit sugar for the reason that it is very widely present in fruit, and if you eat a lot of fruit, you do eat a lot of fructose. Now, fructose intakes in humans in the Western populations have been increasing quite considerably in the last 50 years, and this is largely due to an increase in the supply of high fructose corn syrup and sucrose. Now, fructose is one of the moieties of sucrose, the other being glucose. So if you eat or drink a lot of sucrose, you will be consuming high amounts of fructose. So there are two real sources of fructose in the human diet. There is the natural source, fruits, and then there are the artificial sources, which tend to be sugar-laden soft drinks, cakes, biscuits, anything really with sugar in them. Now, fructose is a molecule, and the fructose molecule in sucrose and in its refined crystalline state is exactly the same shape of molecule that is in fruit. But scientific evidence shows that if you consume fruit, you don't get detrimental effects, whereas if you consume sugar, if you consume refined crystalline fructose, if you, in other words, consume fructose that has been artificially created, put into a powder and then added to foods, you do suffer detrimental consequences to your health, and these can include an increased rate of cardiovascular disease, they can include an increased risk of diabetes, and they can include an increased risk of obesity. So there's clearly a difference between eating fructose from fruit and eating fructose from artificial sources, from refined products. So what's the difference when you consume fructose in fruit in comparison to consuming it in sugar in refined products? Well, really, if we look at fruit, there are two main differences between fruit and refined foods. The first is that fruit contains a lot of water. Most fruits are replete with water. If you imagine eating an orange, most of the orange is actually water. And this tends to dilute the fructose somewhat. It's actually very difficult to consume large amounts of certain fruits. I've never tried it, but if you tried to consume a bag of oranges, you'd probably get either bored or full after eating 2 or 3. However, it's very easy to eat a whole pack of biscuits. The fructose in the biscuits tends to be quite concentrated. Fructose, when it's in refined foods, tends to have low water content, and therefore it's actually very easy to overeat refined foods that contain fructose. So there is a concentration effect within the refined foods in terms of the amount of fructose you can consume. Generally, and it's not always true because some fruits, particularly dried fruits, do contain quite a high concentration of fructose because they've had their water content removed, but generally fruit, if you eat it in its whole form, it does contain quite high amounts of water, and this is one of the effects, I think, that protects our metabolism from the detrimental effects of fructose when we get our fructose from fruit. However, dried fruit is also not really detrimental to the health, so it can't be just the water. And I think the other effect that we find in fruit is the fibre. Fruit does contain a lot of fibre. It has generally fruit will contain pectin, which is a water-soluble fibre, and when we eat fruit, that pectin will absorb a certain amount of water in our guts, and it acts as a physical barrier. The pectin will go, or all the other fibres as well, all the fibres will go into our gut, and they will act as a physical barrier for two main areas. Firstly, they'll stop the enzymes getting into any sucrose that is in the fruit, because some of the fructose in fruit is in the form of sucrose, which is a disaccharide. That disaccharide needs to be digested to glucose and fructose before it can be absorbed, and therefore we need the enzyme sucrase to be able to do that. The fibre can act as a physical barrier to stop the enzyme coming into contact with its substrate, and that slows the digestion of the disaccharide, that slows the digestion and the absorption therefore of the glucose and the fructose. The other way that fibre can act as a physical barrier is it can create a physical barrier against the enterocytes, and that means that once the glucose and the fructose have been digested into their components, they can't actually get to the enterocytes to be absorbed because there is the physical barrier of the fibre there. So fibre does seem to have this effect at reducing the absorption of nutrients. And this really comes to the crux of the detrimental effects of fructose and sucrose and really all refined carbohydrates. Ultimately, if you eat a lot of refined carbohydrates, particularly refined crystalline sucrose, refined crystalline fructose, you increase your risk of developing insulin resistance. Now, insulin resistance is very complex, but it is fairly well understood how it could. There is a number of mechanisms that are fairly well understood as to how insulin resistance forms. The first hypothesis is to do with nutrient overload. If we consume a lot of carbohydrate, and that carbohydrate is in a refined form, it tends to be very quickly absorbed to the blood. Now, those carbohydrates, generally in the form of glucose, need to go somewhere. The body doesn't like having its homeostatic mechanisms taken out of their normal range, and as your blood sugar levels rise, the body wants to push that sugar away from the blood into the cells. Now, if you consume a lot of refined carbohydrates, the resultant glucose and other sugars as well will be pushed into the cells. Now, the cells in response will have a large amount of energy, and they will oxidize that energy and they will push it through the energy producing pathways. Now, those energy producing pathways will produce ATP. Ultimately, electron carriers will pass their electrons down the electron transport chain, and that will produce energy which will allow the production of ATP. However, during that process, free radicals are produced. And those free radicals are damaging to the cell if there isn't adequate antioxidant defences. Now, constantly consuming refined carbohydrates and putting a large nutrient overload into the blood will cause large energy production in the cells, and this will produce a large number of free radicals, and eventually the antioxidant defences of the cells will be depleted and the cells will start to undergo damage through free radical damage. Now, the cell has a defense mechanism against this. The free radicals may actually feed back and inhibit the insulin receptor, and in doing that they decrease the nutrient uptake of the cell, and that decreases the amount of energy that will flux through the electron transport chain, which reduces the free radical damage within the cell. However, that insulin resistance then has knock-on effects on many metabolic pathways in the body, and it's that insulin resistance, the development there, that likely causes Western lifestyle diseases. So that's one of the mechanisms whereby refined carbohydrates may cause insulin resistance. Another mechanism is related directly to fructose. And fructose will be absorbed. It's actually absorbed and generally taken up by the liver. And the liver can do two things with fructose. Firstly, it can convert it to glucose. And if you're in a situation where you've just performed physical activity and you've depleted your liver glycogen, that's the preferential pathway that will be taken by the liver. It will take the fructose that you've just absorbed and it will convert it to glucose, and then it can resynthesize the liver glycogen, or it can actually push some of that glucose back into the blood to raise blood sugar levels. And this is probably one of the protective effects that exercise has against obesity and insulin resistance. It actually depletes glycogen and therefore allows any fructose that you do eat to be converted into glucose. However, if you haven't exercised and you have led a sedentary lifestyle or a sedentary week or day, and you have a replete glycogen store in your liver, and there's no need for extra glucose because your blood glucose levels are high, the fructose will be pushed down the de novo lipogenesis pathway, and this will produce fatty acids. These fatty acids are exported from the liver Some of them accumulate in the liver and they cause non-alcoholic fatty liver disease. The other fatty acids may be either synthesized into triglycerides or pushed into the blood, and they will accumulate in skeletal muscle. Now, it's the accumulation of the lipids and the fatty acids that result from the de novo lipogenesis pathway that may interfere with the insulin receptor signaling pathway inside cells. The mechanism is not fully understood, but there is good evidence that these fatty acids can inhibit the insulin sensitivity of cells. So fructose can directly cause insulin resistance, and we see this when we look at animal experiments where they're fed high amounts of fructose. The fructose within a number of weeks, there's been a number of rat studies that have been done. If you go to my blog and you search for rats and fructose, you will find 3, 4, 5, maybe more studies that I've talked about where rats have been given fructose, and within 2 weeks they've developed insulin resistance. So we know in mammals that fructose in quite high amounts causes insulin resistance. Now, the fructose given to these rats was quite a high amount, but it was calculated that the amount that they had in their diet was similar to that you might find in humans who were consuming quite large amounts of soft drinks. So it wasn't outside of the realms that you might actually be able to get in your diet as a human. But obviously, if you eat less fructose but you eat it over a longer period, you may develop insulin resistance as well. So that's really why refined carbohydrates, including fructose, are damaging to the health, and it's one of the reasons why fruit really should never be converted into fruit juice. When you take away the fibre and you concentrate the sugars in the water, in other words, you're taking away some of the water and some of the fibre, or all of the fibre, you're effectively turning the fruit into a soft drink. When we look at studies that compare soft drinks with fruit juices, we find there's no effect. There's no difference between the effects they have. They both have detrimental effects on insulin sensitivity. They both have detrimental effects on weight gain. And both fruit juice and soft drinks are associated with obesity, with type 2 diabetes, and with cardiovascular disease. So this is why you should always eat your fruit in its whole form. And this is why you should really classify fruit juices with soft drinks. Now, going back to exercise is protective of obesity, it is protective of insulin resistance, and this goes back to something that Dan Duchaine said, that there's no such thing as a bad carbohydrate, only a mistimed carbohydrate. Fructose, refined carbohydrates generally throughout the day, throughout your lifetime, are going to be detrimental. However, there are times when refined carbohydrates and fructose are actually beneficial, and that's after you've performed exercise. When you exercise, your liver glycogen is depleted, your blood sugar levels go down, your muscle glycogen levels are depleted. At that time, there's a window after you've exercised. It probably goes on for 2 hours, maybe even more, 4 hours, 6 hours, depends on the type of exercise, the duration and the intensity. There's a window of opportunity there where you can take refined carbohydrates and they're actually beneficial. Fructose after exercise is known to preferentially regenerate liver glycogen. Refined carbohydrates are absorbed more quickly, as they are normally, and that's actually beneficial after you've exercised because your body needs the carbohydrate to replenish its glycogen. So really the situation between refined crystalline fructose and fructose found naturally in fruits is quite complex, and it depends really what type of fructose you would consume would depend on what you'd actually done in terms of physical activity. So I hope that was interesting. There is a lot more to carbohydrate metabolism, fructose metabolism, and the detrimental effects they have than most people consider. Fruit is obviously, I personally think that if you ate lots and lots of fruit and you picked particular types of fruits that maybe had lower fibre content and lower water content, I do think they would have a similar detrimental effect to fruit juices, to refined foods, to refined carbohydrates. If you look at bears, for example, before they hibernate, they do consume quite a lot of fruit to get to put on body weight. So you can put on body weight from over-consuming fruit. I would suggest that things like apples, oranges, pears are quite difficult to overconsume. But if you look at fruits like bananas and grapes, they do have a higher sugar content and a lower fibre content and a lower water content than many other fruits. So I think you have to see that this picture is much more complex than people make it out. Refined crystalline fructose is generally bad for the health. Refined crystalline sucrose is generally bad for the health, but there are times when they are beneficial. Refined carbohydrates too, generally I would avoid them from a healthy diet, but again, after exercise they do become beneficial. If you avoid soft drinks and fruit juices and refined carbohydrates generally, you will probably do a world of good for your health. Stick to eating, if you want to eat fruit, if you want to get the benefits of fruit, stick to whole fruits. Dried fruit in limited amounts is okay, but again it can be easily overeaten. So I hope this information was useful. It's really very difficult to give specific guidelines on these types of things because the metabolic pathways are so complex and they interact. Everyone has a different biochemical makeup, and therefore it's very difficult to make these recommendations. But I've tried there to give an overview of fructose metabolism, so you can now make the choices as and when you think are required in order to best choose the carbohydrates. And if you remember Dan Duchesne's mantra, there's no such thing as a bad carbohydrate, only a mistimed carbohydrate. That's probably the best advice that you can remember. So I hope that information was useful. As always, if you've got any comments on this video, please leave them in the comments box below, and I will try to get back to you as soon as possible. And I shall see you next week for another video. Until then, take care.